going, everybody? Thank you so much for coming to Developer Day at this GDC 2018. I'm Nathan Martz. I'm a product lead on the immersive computing platform team at Google. And I'm going to talk to you guys a little bit about augmented reality. Before I do that, though, I'd like to ask everyone, please silence your portable telephonic noisemakers so that everyone else can hear the talk just as clearly as you can hear your phone. So thank you so much. Again, my name's Nathan. And I want to start with a very basic observation, which is that phones have become dramatically more powerful over the last decade, right? We've all seen this happen. We have dramatically faster multi-core CPUs, programmable GPUs, more storage, faster connections, and all these things have dramatically changed the way that we build games on mobile. But one thing that hasn't really changed very much in that time span is actually the phone's understanding of the world itself. If you think about the sensors that we have on phones today, camera, GPS, accelerometer, that's basically what phones had a decade ago. Except until actually very recently, which thanks to the confluence of increasing onboard compute and increasing quality in sensors, we're at the cusp of what we believe is going to be the next major shift in mobile computing, and that's augmented reality, right? By combining the power of a modern mobile CPU with advances in machine learning and computer vision, we can actually help phones see and understand the world the same way that we do. And as game developers, that means that you finally have an opportunity to leverage that understanding to bring digital information, your characters and your IP, into the real world, right where it's most accessible and useful for your players. So as a game developer, this is going to open a lot of awesome opportunities. You can fundamentally blur the boundaries between the real world and your game, right? You can bring your characters into the same world that your players already inhabit. You're going to be able to let players experience the game from a different perspective and actually leverage things like the position of a device in space, the physical structure of the environment that your player's in, to create brand new mechanics, and mechanics that in turn we hope will spawn entirely new genres. And because AR is about the real world, it's not just about the places, it's about the people in it. And you can leverage an understanding of people to create interactive experiences based on identity, expression, emotional context, and weave that into the larger narrative for your game. We know this to be true because actually at Google, we've been doing smartphone AR for about 4 years now, since 2014. The challenge, though, is that historically, smartphone AR has required a custom hardware sensor. We called it Project Tango. And that custom hardware sensor limited the rate of adoption and the rate at which the ecosystem could scale. But today I'm here to talk to you about a really exciting opportunity doing augmented reality at Android scale thanks to a new technology we call ARCore. And ARCore is a brand new augmented reality library for Android. And as a developer, it gives you 3 foundational and very powerful capabilities. The first of them is motion tracking. ARCore actually combines data from the color camera on your phone with the IMU to compute a 3D position and orientation of the phone in space. And that's what actually allows you to place a digital character and walk around it, get closer, get further away, and have that character feel anchored in the real world, just like any other piece of the environment. But even though motion tracking lets you place objects in the world, you need to understand the world itself in order to create rich interactions. And so the second thing we provide, we call environmental understanding. And this is a set of algorithms that allow you to do things like get a sparse point cloud for the scene, do raycasts against it, and even detect really important components of the scene like the ground or the table planes. And with that, you can actually create your interactions, do physics, UI, all in a 3D spatially aware context. The last thing that we provide is called lighting estimation. And this is a set of algorithms that allows you to understand the ambient lighting in the room. So you can actually allow your virtual objects to feel like they're lit and shaded in a way that integrates with the real world. And you can even use it for behavioral cues, allowing your characters to respond to changes in brightness in the lighting environment. We know, though, that as developers, you care not just about a technology, you need an audience. And so I'm very, very proud to say that ARCore today runs on more than 100 million Android phones. Many of these are flagship phones from all the major OEMs in the ecosystem. So if you build an ARCore app today, you can already reach an audience at scale. And we're not content to stop with 100 million phones. This year, we're partnering with the entire Android ecosystem, many more OEMs, to significantly increase that number of supported devices over the course of the year. And we know also that a lot of you are now thinking about bringing your games not just to the established, developed markets, but to China, which may be new for a lot of you, but seen as a new opportunity. And so we're very happy to announce that we're going to be bringing ARCore to China later this year in partnership with 3 really key OEMs, Huawei, Xiaomi, and Samsung. Now, all this stuff is great, but you're developers, you actually want to make apps and games, and to do that, you need SDKs. And we have SDKs for every IDE that you care about. So if you're a C programmer working on your own game engine, we've got you covered. You want to do Java app development, we've got an SDK for that. Or if you like a commercial game engine like Unity or Unreal, we have really high quality native integrations built in close partnerships with both Unity and Epic. And all of this is going to allow you to build your own app really efficiently, effectively, and deploy it to an audience that's already over 100 million devices large. Speaking of that, I want to talk a little bit about some tips and tricks, things that we've learned about how to build AR-enabled apps efficiently and effectively. And these are all things that I hope all of you are thinking about, ready to get started building an app. And these will hopefully help you avoid some common pitfalls, save you time, make you more effective. So on the design side, a few tips we want to share. The first and most fundamental is that anyone building an ARCore app really wants to think about your onboarding flow. For your players, ARCore is a brand new modality. Even basic things like you can walk around are new ideas to your players. So make sure that you really invest in onboarding that's natural for your game so that your players feel comfortable and at home and actually get the most out of this new modality. The second thing you want to think about a lot in design is the scale of your experience. And most ARCore experiences are going to fall into one of 2 buckets, either table scale or room scale. Table scale is great for basically tabletop gaming. It's a very predictable environment, right? Most people's tables are of a similar size. They tend to not have much clutter. They're all at a uniform height. And that, if you want a very kind of predictable experience, tabletop is a natural way to go. Room scale is kind of the opposite. Rooms have a greater diversity of objects. They have multiple planes at multiple heights. There might be a table in the room that's just part of the play surface. And this has a lot of, I think, creative opportunity in the same way that it has technical complexity. And so when you think about your experience, try to decide up front, are we fundamentally building a room scale or fundamentally building a table scale experience? As you think about either one of these things, you're going to wind up placing virtual objects that need to feel anchored in the real world. And there's actually a technical concept called anchors in all of our ARCore SDKs. And for you developers and programmers in the room, one thing you want to really be careful about is every time you say, this is a virtual object that needs to make a really tight connection to something in the physical world, you always want to programmatically create an anchor at that point. And once you do that, our underlying motion tracking algorithms will make sure that it stays fixed in space, even as the camera moves, even as the lighting changes, all that sort of stuff. And of course, once you've placed these objects, you want them to be believable. A lot of what we do is we create believable synthetic realities. And in AR, that means that your characters need to not just be like lit well, they need to be lit well in a way that matches the environment, right? You need to establish a physical and visual identity consistent with the environment that the player is in. And players can be in any environment in the real world, which is a pretty amazing amount of diversity. So there's really 2 things you want to think about, shadowing and lighting in that order. With shadowing, fundamentally contact shadows are what establish the visual connection between a virtual object and the physical world. And so you really want to make sure that you think about a good contact shadow or self-shadowing or ambient occlusion solution so that wherever your character's feet are, or tentacles, or paws, whatever they are, that they're actually making contact with the ground and the world around them. And the second is the shading on that character itself. You want to think about physically based rendering and image-based lighting as a way to ensure that the shading model on the object matches the real world, and that the lighting that the real world sees is the same one that's applied to your character. And we've got some great samples of all this stuff online. So now that you get into building your app, a few things we want to highlight. First off, we know for many of you, especially when you're prototyping or if you're an indie developer, mobile-friendly 3D assets are a big challenge. Well, we have an entire site called Poly with thousands of free, very royalty-friendly, license-friendly 3D assets. Bruno after me is going to go into this in a lot of detail, but definitely check out Poly to help yourself get off the ground. We have runtime SDKs and APIs for it. It's pretty awesome. You need to iterate quickly, right? You actually want to try your ideas out, and in some cases, you want to try your ideas out in a room that you don't have available to you at your desk. So we've actually extended the Android emulator that comes with Android Studio with support for ARCore. So you can actually build an app and test on a virtual AR device without leaving the comfort of your desk, even though it takes you to an entirely other place. And this lets you iterate on your core game loop, your core ideas, within seconds rather than minutes. It's pretty awesome. And then the last tool I'll talk about is graphics debugging. AR is a fundamentally visual medium, and as you get into especially the lighting and shading, you're going to want to debug your graphics pipeline and understand what's going on under the hood. So we've built a tool called Gapid, which allows you to quickly visualize, inspect, and diagnose your rendering in a way that's independent of the underlying hardware. So regardless of whether you have an Axios or Qualcomm or whatever-based phone, Gapid will work on it with ARCore active. So the last thing I want to talk about is actually launching your app. Of course, that's the most important part, and there's two main modalities in ARCore. They call them AR required and AR optional. So the simplest model is an AR required app, and if you say like, no matter what, my app fundamentally requires ARCore, it doesn't make sense without it, you're an AR required app. And for you, when you configure your manifest for AR required, on the Play Store, we'll actually make sure that only ARCore certified devices can see that app listing entry. So you don't have to worry about users downloading it and not being able to use it. And in fact, for those users, we'll bundle the core AR services in with the download of your app so that as soon as that download is finished, the user is ready to play. You don't need to do any extra initialization or checking. You can just get started. Many of you, though, are going to want to use AR in an optional fashion as an enhancement to an app that runs on a wider variety of platforms, maybe the entirety of the Android ecosystem. And for you, we have the similar manifest settings where you can say, I support ARCore, but it's optional. And what you'll need to use is some APIs in our SDK that allow you to check to see, like, is this device ARCore capable? Are the ARCore services installed? And if it is capable, but they're not installed, we actually have a nice pop-up dialog box where users can install those services without leaving your app. So you're not giving up traffic, you're not losing engagement, you're still able to add ARCore at scale, kind of whichever modality you want to use. And of course, we're all gamers here, right? Not just game developers. And if you want to experience ARCore for yourself, live today, we have over 100 apps on the Play Store that are all built on top of ARCore, built from some of the best developers. In fact, I think a number of people in this room are part of this list. So go to the Play Store, check out ARCore, and you'll find a number of great, really, really exciting and innovative apps and games to check out. So with that, I want to thank you very much and hand it over to Bruno.
Thanks, Nathan. All right, so we're going to talk about the Poly API. When I was a kid, I always liked to develop games. I think games is something that I've always been doing. This was like back in the times of BASIC. And my friends and I would get together, and we would try to make a bunch of games. We kind of knew the programming part, but we really had some difficulty with the art. So often we would come up with a game, and then we would have like these nice code, but then we would imagine imagine if this really epic dragon comes out at the player on this scene, but the reality of our graphics were something more like that. Sometimes you can work around that, sometimes you can say, oh, that's not a dragon, that's more like a slug-like thing. Sometimes you can work around that stuff, but other times you can't. So I'm the kind of developer who really likes cubes. So with my skills, I could develop a game that's about a cube that shoots other cubes to protect those bigger cubes from being hit by the smaller cubes against a background of cubes. If you think that there's no way that that's a viable game, you would be wrong. I introduce you to Cubic Pilot. Not only is this thing a thing, but Google in some official capacity actually endorsed it because it's a sample for the Play Games API. What I'm saying with this is that we, as developers, we all have that book. And we have all read that book, and I have that. And we know that sometimes the best way to do, sometimes the only way to do games is to apologize for some lack of graphics. So some people, when I show this, what they tell me is, have you heard about something called money? And I'm like, no. Tell me about it. And say, well, money is this magical thing that you can exchange for goods and services. For example, if you don't have assets, then instead of reading that book, you can go and exchange your money for some assets that somebody else has made. That's how the economy works. And they say, well, that's interesting, but this is the traditional asset acquisition model. And there are some problems with that traditional asset acquisition model. One of them is that it requires money. The second problem with that asset acquisition model is cats. And by that, of course, I mean if you ever actually try to buy assets online. You can't just buy one cat. That's not a thing. You have to buy Super Deluxe Cat Pack 2000 with 700 fully rigged animated cats for a very high price. And I have nothing against cats, but 700 might be a bit much. Third reason is prototyping. Sometimes you're still in the prototyping phase of your game. At this point, I might not really know if I want to make a game about cats or spaceships, or maybe cats that fly spaceships, who knows. But anyway, I'm not ready to commit to any particular cat, and much less 700 of them. And the fourth reason is runtime. What happens if you've never actually thought about cats at all during development, and now at runtime, the user wants a cat of all times. Now they want it. So how do you actually load a cat at runtime? This is why I like Poly. So Poly is Google's gallery of 3D assets, and there's everything there. So if you're a developer, if you're making a game, you can go there and you can find assets for pretty much everything. If your game has cups of coffee, if your game has knives, if your game has cameras, space shuttle capsules, if your game in any way involves mustaches, you're going to find everything there. And how do those awesome assets get there? Well, users can upload them from Blocks, which is our 3D VR asset creation app, from Tiltbrush, and people can also upload OBJ files that they make using Blender, Maya, and other programs. Even I made my own contribution there, as you can see. So if you ever need a cube, you're covered. Just use that one. So, and all of that comes at the, I'm sure you'll find, very reasonable price of nothing, $0. And if you mention this talk, you get a 50% discount. And the assets are free, and they are licensed, most of them are licensed under Creative Commons, which means you can use them for free in your app, and then all you have to do is give appropriate credit to the authors. So Poly is great. How do we get that stuff in your app? So it came to our attention that developers love APIs. So we decided, why don't we have an API for Poly? That makes sense, right? So we put together our most creative minds to come up with a name for this. What are we going to call this API for Poly? And what we came up with was Poly API. So you can find all about it on that URL. So it's an API that lets you load those assets into your app. But what can that API do? So for example, this is an example from NMVR. As you can see, you can, at runtime, find out a bunch of assets, and then you can import them into a scene, and then let the user use them to create a scene. So how does the API actually work? Whenever you make a request to that API, it's going to be handled by one of our blue robots in the data center. That's an actual picture of what's going on in the server right now. And so you can use that API to find the assets you want. You can specify a keyword, you can specify category, type, complexity of any format that you want. And then, of course, and this is probably the important part, you can download the assets and then import them into your scene. There's also a curation flag. So the curation flag is something that indicates that the asset has been evaluated by a human being in our team, not a blue robot, and that has been determined to be a good asset. So if you want to filter for only like good assets, you can use that curation flag. It's the same flag that filters the web page. The API is naturally cross-platform. It's basically a REST API, so you can access it from basically any device that can do internet connections. If you're using Unity or Unreal, we do have Poly Toolkit, which is a full-fledged toolkit for the engine that wraps up the API and has some convenience helper methods. So you can do this everything from the queries to importing and downloading. And if you're not using one of Unity or Unreal, we also have samples for many of the other platforms. So Android, ARCore, iOS, SceneKit, ARKit, Web. So we have samples for all of those. So this is what the API looks like. It's basically just a GET request. It has a bunch of parameters. So you can specify the keywords that you want to search for, if you want to curate it stuff or not, and so on and so forth. Just a GET API. What you get back is a JSON file containing like a description of the assets that we found, and then it has URLs to download the actual files that make up that asset. So this is the workflow. Just list the assets, find out the kind of assets that you want, then decide which ones you want to import, then download the asset files and display the asset in your scene. It's a pretty straightforward workflow. This is an example of Poly Toolkit running. So you're going to see that in Unity, you have this editor window where you can select assets, and then you can click and import them into your scene directly from the Unity UI. So this is an example of importing this garden directly from the Unity UI. It takes about 3 clicks to do that, and then you have that garden in your scene. There's also the runtime API on the Poly Toolkit. So it's pretty much what you would expect a C# API to be like. This is a request, for example, to get just some random cats. And if you run that with the keyword cat, you get some random cats. You can also be very specific. Like if you're very, very picky in your taste for cats, you can specify any of the filters you want, and then you're going to get such gems as fancy cat, space cat, creative cat, galactic cat, and a bunch of other ones. And there's a lot of flexibility on the kinds of apps that you can build. For example, you can build like standalone apps, you can build VR apps, you can build AR apps. So these low-poly models are great for AR apps. So if you're using ARCore, that's a great way to load assets. We actually made a couple of games with this. This is an escape the room game that we made with this API. So it's pretty much like you're stuck in a room in VR, and then you have to go and escape the room by solving the puzzles. It's a very cheesy game. And you can see that you can use the objects and add some lighting, and you can already create some very interesting effects with it. This is another one. You might want to create like this atmospheric VR game where you have to, like in this misty landscape, and then you have to go up the stairs and find this cat. And then, I'm not sure, I didn't really think this came through, but presumably the cat will ignore you at that point. Yeah, I'm just illustrating like the wide breadth of games that you can make. So what this means for me, of course, is that I can stop making games like that, and hopefully I can step up my art assets and start making games that are more like that, all using the Poly API. So go ahead and check out developersofgo.com/poly. You're going to find more information about our API, and I'm sure that your players will like it. And speaking about players, do you know what's even better than one player? More than one player. So up next, I'd like to invite Aaron, who's going to talk about multiplayer game design. Thank you very much.
Nice job. Thanks for warming them up. Here's a question. Why do we play? Why do humans and hundreds of other species play games? I mean, games are fun and they're relaxing, but why have we evolved to enjoy games? Well, for decades, scientists thought the answer was that by playing, young animals were learning the skills that they would need as adults, hunting and stalking, fighting and fleeing. And in the 80s, a researcher testing this took some tiger cubs and separated them while they were young and kept them from playing. And as adults, those cats could hunt just fine. But what they could not do and what they could never learn to do was to be social. You see, play is not how we learn physical skills. Play is how we learn social skills. You see, survival is not a single-player game. A strong social system is critical to succeeding in the wild, and play offers us a safe place to build and nurture our relationships. Ask anyone in a long-term relationship, and they will tell you play is critical to love. So if social skills are the why of play, then as designers, we need to deeply understand the how of human relationships. And that journey starts with a number. Our social networks are surprisingly consistent. Around the world, we all have about 150 stable and meaningful relationships, and after that, we actually run out of brain power. Each new person that we try to add pushes somebody else out the back. It's known as Dunbar's number. And I see a few of you nodding in recognition after the scientist who discovered it. Of course, not all friendships are created equally. We separate our relationships into different levels, and they're sorted by trust. The more I trust you, the more I'm willing to invest in our relationship, and the more willing I am to show you my innermost self. This has the somewhat unfortunate name of the social penetration theory. And it, too, is remarkably consistent around the world. All of us have about 5 best friends that we trust implicitly. Around that, we have a larger ring of friends, about 15, who we trust but not quite as much, and then a ring of 45 to 50, and then that final ring of 150. And these layers are very clearly separated from their neighbors, defined by how much we trust the people in each group. This is the fundamental truth of our social lives. First, we explore safe topics together to see if we like the same food or music or games. Then we learn to rely on one another, and finally we learn to trust one another. And trust is the lifeblood of a relationship. So I wondered, if this is the scientifically proven arc and structure of human relationships, then as designers, could we learn to use this to build a better multiplayer game? Well, I've actually been at Google for around 2 years working on this problem. Along the way, I asked Raf Koster about this, and he was intrigued by the concept and agreed to join me in trying to find an answer. Together, we made a list of about 200 game mechanics, and for each one, we asked, how much trust does this call for? The result, based on the answer, we mapped it to each of these stages of human relationship, and the result is a map from real human trust to game mechanics. It's a brand new design lens that I'm proud to share with you today for the first time ever, and we call it the trust spectrum. By building games that support relationships at all levels, we found we could provide much stickier and more compelling games for our players. What's more, because we worked with the grain of human relationships, as they truly exist in the real world, people left the games feeling more connected than they did before. So let me show you how. First, we took these stages that become more intimate as you move up the scale and laid that across a new chart left to right, like this. As we started to analyze this big pile of mechanics we had made, we found that they clustered into families like this. Remember, each design axis represents dozens of mechanics that impact player trust in similar ways. For example, let's take that top row, symmetry, which is the amount of overlap in capabilities that players have in-game. Now, I'm talking about the rules of the game, not player skill here. Symmetry is about whether we can all do the same things in-game or very different things. At low levels of trust, everyone can pretty much do the same thing. Some of us might have advantages in different areas, but any player in any role can pretty much finish the game. At the medium levels of trust, we get to things like team-based shooters. We can all run and gun, but each character brings something unique to the team. At the highest levels of trust, you have almost unique abilities like character classes in RPGs and MOBAs. At this extreme level of asymmetry, you get interdependent play strategies like tank, healer, and DPS. Now remember, every one of these rows has the same level of detail and complexity, and what's more, they interact with each other in subtle and nonlinear ways. So for example, let's go back to symmetry. Think of a relaxing puzzle game where each player can do something unique, like open doors or pull levers, and the players can work together as a team to solve puzzles and win the game. Now contrast that with an RPG, which requires strict timing and precise coordination. These are both highly asymmetric games, but one is a very low trust experience, and the other is extremely high trust. So I hope by now you're inspired to go try some of these ideas in your multiplayer games, so let me give you a few tips on how to get started. First, and most important, build your game so that players can succeed no matter what stage their relationship. However, do not incentivize them to move beyond the playstyle that suits them. The goal of the trust spectrum is not for players to advance up it. If you give them points or otherwise incentivize them to move up the scale, they will, and this doesn't work. We are not wired to be best friends with everybody. Second, try to cover the full spectrum so there's things to do for all kinds of players. If I can play your game with all of my friends, then I probably will. However, be careful not to mix high trust and low trust experiences together at the same time. It will absolutely confuse your players. Third, if you're at a loss about where to get started, think about the ways that players connect in your game, whether it be through friends lists or different game modes. And then for each of those, think about how many players are interacting at once. If you have, say, a big boss battle scene where 150 players can all pile on and contribute, you're going to want to use low-trust interactions between the players. But if the team sizes are more like 15 or 5, then use higher trust mechanics to create a deeper connection between those players. So basically, don't use high trust mechanics in large groups. It's not appropriate for a big group. But also don't use low trust mechanics in tight and intimate gameplay. It's too shallow an experience, and your players will basically get bored and disengage. Finally, for all my producers out there, be warned, the higher you go up the trust spectrum, the longer it's going to take to make your game. A high-trust game, we found, can take 3 to 4 times as long to make as a low-trust game. And this largely comes from that asymmetry that I was talking about. A fully asymmetric game is like building multiple single-player experiences, each of which needs to be balanced and perfect, but they also need to work together as a system. And finally, don't forget to check for interactions between your systems. We actually found it was pretty easy to use 2 low-trust systems or mechanics that interfered with one another and accidentally created high-trust experiences. So here's a few more resources to keep you going. First, Raf has graciously agreed to share in great detail, I'm talking 11,000-word blog post on his site, rafcoster.com. Of course, others have gone before on this path. In particular, I call out the Project Horseshoe report on this topic, which takes a slightly different angle on the same subject. And I also hear Dan Cook is giving a talk on this topic at 4 p.m. on Thursday, which I know I will be at. Multiplayer makes games stickier. Stickier games have higher engagement and more replay. So using the trust spectrum, you can build games that help players meet new people and nurture their relationships. So I'd like to leave you with the question, what if you could build games that are not just good for your bottom line, they're good for gamers? And if you'd like to talk about this some more, I will be at the Google booth on Thursday from 12 to 3. And up next, I'd like to welcome Maria to the stage from Daydream. She's going to bring up some of our partners, and they're going to share their experience making AR games. And I thank you very much for listening.
Hi, everyone.
Hello.
Really excited to see all of you joining us today for a wonderful conversation. Thanks for making time. My name is Maria Assig. I work at Daydream team focusing on gaming vertical across VR and AR platforms. And actually today, our team shipped an AR destination on Google Play Store, where you can find multiple experiences across gaming, utility, self-expression, and other verticals, highlighting new developers and someone who actually has experience working in this space, to delight you, to bring new characters and interesting games to the world around you. I'm honored to introduce my speaker to you today. Her name is Samantha Gorman. Samantha's works extends across narrative, cinema, games, virtual reality, and media scholarship. Samantha is a co-founder on the indie art collective Tenderclaws, who are working on mobile apps such as Pry, who delivered a wonderful mobile VR experience called virtual reality, actually one of the most acknowledged mobile VR games today. And besides being busy at Tenderclaws, shipping all the great experiences, Samantha holds a Master of Fine Arts degree in writing for digital media and can be found at the University of Southern California, completing her PhD in media arts and practice. So we are all talking that AI is quite new, that it's just coming to the market, but you, Samantha, actually worked with this medium for quite a long time. Can you share with the audience what originally brought you to this medium and share your probably first project? What was it?
Yeah. Thanks for having me. So when Google Glass was first announced, I actually did a performance piece at the Geffen Contemporary, which is this museum in LA, with this poet named Vanessa Place. And we used the capabilities of Glass to record the audience, project it back to themselves, and then augment that projection with funny search queries for like, okay, Glass, that were in the text of what we were using. And I think my interest in AR was coming from the fact that I think there's a lot of really awesome use cases for room scale and environmental storytelling. But what does it mean when you can be in the room with someone live and you can actually have an AR layer of information about that person, or maybe some thoughts about what they could be feeling? How does that change the dynamics of you and the other person in your actual physical space as a player?
Wow, that's really interesting. And your team is constantly experimenting with this medium and actually emphasizing this connection between live dialogue, people, and the new technology. Speaking of which, you've just premiered your new title called Tenda during Sundance Festival. Can you tell us a little bit more what inspired you here, more about this project and your plans for it?
Yeah, sure. So Tendar is actually a social AR experience, sort of going off of the original interest with that Google Glass project. And it uses a front-facing camera to put a filter on the face of you and your partner, give some kind of information about the room and what you're feeling. And then that is turned into fish food, which is fed to an AI fish that evolves over time, depending on the emotion flakes you feed it.
Oh, wow. So much emotion. How does fish react to different experiences? How it goes with the flow?
Yeah, it depends on what mood he's in at the time.
Great. So technically we have an AR cat version, but in the fish.
Yes.
By the way, for everyone, we have Tenda as one of the AR demos at Google booth in Southern Hall, booth number 823. So if you have time, highly recommend you to check it out and see how AR brings people closer to each other. Speaking of the technological part of the game, it's pretty much packed with different new platform features and design decisions. How was your experience working with ARCore? Was the tool set actually helpful to deliver on your creative vision?
I meant to say, and this is actually related to that question, that the Tendar version at the booth is a companion piece to the full app, which is a single player and has AR content that unfolds over multiple play sessions. And that is related because we had to really think about how to put the characters and models into the space that was meaningful for the player's environment. And ARCore actually took care of that technology really easy and simply for us, which then it made it so that a lot of the outstanding questions were actually design decisions in terms of like, okay, we have a character in space, but we just don't want it to think about the, like, we want it to know that the space it's in is the player's world space and not imagine it as anything else. So how do we have that character meaningfully interact with the player's world, and what type of knowledge can we give it about not just the dimensions of the space, but what might be in, like what objects or things might be in the world of the player?
Oh, great. Yeah, that's fantastic. So given your current experience and all the knowledge in the space, what do you think are the best and most exciting applications of AR in like short-term, mid-term, long-term spec?
I would say I've seen some really cool, like, there's been some really cool like tabletop games, but a lot of the really interesting things I've seen are about like enterprise, designing for enterprise, and being able to really like pick apart and get the dimensions of objects. And in long term, I think sort of how we've adapted cell phone use in the US sort of overnight, it seems like it's become a mode of how we interact with our world and engage with our world without us thinking about it too much. I think in long term, there'll probably be elements of like AR applications or hardware that will be able to do that. And we'll just have informational layers, you know, without even analyzing it. So.
Yeah, it's always inspirational to hear about your work and your thoughts. Thanks a lot for joining us today and for your time. For everyone, once again, stop by our booth, play some great games. And if you have any questions to me or Samantha, feel free to stop by after the talk. Thank you. And right now, I would like to welcome Clementine on stage from our Maps team, who will tell you a little bit more what are other ways to bring games to real world. Thank you.
All right. Does my mic work? Now it does. Hello, my name is Clementine, and as the slide says, I work for Google Maps. All right, raise your hand if you have ever played Pong. Excellent. OK, now I want you to think in your head about how you would describe the game world in Pong. Not the game, but the game world. So this is really where gaming started, with two-dimensional experiences where the game world was really a single screen. Later, we evolved to still two-dimensional, but much more complex game worlds, where that single screen became one of many, part of a larger game world. And today, there's an ever-increasing demand for realistically modeled 3D environments on a bigger and bigger scale. Now, over the last 40 years, innovations in technology have enabled a huge increase in the ambition and scope and detail of the game worlds that we see. And in response, games and game worlds have dramatically increased in interactivity, in complexity, and in just sheer breadth and size. Some of those games, like you saw, have become era-defining and brought the industry along with them. But fundamentally, game developers spend a lot of time and energy and money modeling game worlds. And they do this because, in part, the detail and dynamism of your game world defines how good your game will end up being. So as it turns out, at Google Maps, we also spend a lot of time modeling a world for our users to explore. We spend a lot of time doing this, and we know it really well, and we know that when you do this by hand, it can produce breathtaking results. But it's also breathtakingly expensive. And it's getting more and more expensive as we try to do this on bigger and bigger scales. So think about, for example, the world in Grand Theft Auto 5, which is still one of the biggest and richest game worlds that's ever been created. At launch, that game world was about as big as downtown Manhattan. So what if we could scale the art of creating game worlds? What if there could be game worlds in which detail didn't have to be balanced with size? All right, now hold that thought for a moment. In parallel to that whole progression, mobile phones have gotten really good, which you've seen in other talks today, right? They're getting so good that developers can begin to sort of blur the lines between a game world and the real world. And across the mobile ecosystem, we're seeing digital content brought into the physical world. And this is being done by smartphones that are so powerful that they can convincingly blend realities. And at Google Maps, we specialize in reality. So for over a decade now, we've been relentlessly combing the world, finding all of its details, and delivering those details to you on your phone so that you can explore no matter where you are. All right, so backing up, looking at these two progressions, we at Google Maps decided we could help. And that's why we set out to create an offering specifically for gaming, to help developers build game worlds based on the real world, powered by Google Maps data and backed by Google Maps infrastructure. Our goal is to turn the real world into your playground so that you can take that richness of reality as your starting point and go from there. So I'm going to show you a short video to sort of kick off what this means. All right, I really like the dragon. So with this product, we wanted to both help developers take their game worlds to the next level, but also make it easy to get started because geodata is really complicated. So we went and talked to tons and tons of developers, and we built a product based on what we heard. And what we heard loud and clear was that you basically wanted help with three things. So first, you need access to Google Maps data, that rich and accurate and living model of the real world. So critically, our data is really fresh. We make about 25 million updates a day to reflect the pace at which the world is changing. And that data relies on the same infrastructure, in this case, as the billions of requests made to Google Maps a day. Second, and this was something that we heard resoundingly, you wanted that data in Unity. So we've built an SDK that does all the heavy lifting for you. No Google Maps expertise needed to get started. And this allows your team to focus on doing what they do best, which is creating a rich and immersive game. And third, and this one's really important because it's really hard, we help you design interactions around real-world places. So note that this is a monumental challenge. Like, think for a moment about where you would end a mission in a suburb that you had never been to before on the other side of the world. It's really hard, and doing it well requires knowing a lot about the player's immediate environment and also their larger context. So we help you design gameplay around real-world locations so that you can choose places that are appropriate, unique, and fun to play no matter where your players are. Now we're going to take a look at how to build a game. So I'm going to bring Patrick up on stage to show you.
Hi everyone, I'm Patrick Donlan, engineering lead for Google Maps APIs. I'm super excited to be talking to you today about what we've been working on. So imagine that you're building your very own location-based game. The first thing that you're going to need is high-quality map data. As Clementine mentioned, we're bringing Google's rich, accurate, living model of the real world into Unity. I'd like to show you exactly what that looks like. So if we roll the video, what you're seeing here is Manhattan, rendered by the Maps Unity SDK inside of a demo app that we put together for this talk. Our SDK makes it really easy to turn this blank canvas into a stylized game environment. Here's an example. So notice how custom textures have been applied to buildings, parks, and roads to create a futuristic look and feel. Our SDK gives you fine-grained control over this process by modeling each map feature as a separate game object. So what was previously a bland street corner is now the setting for a sci-fi adventure. Or, if you prefer fantasy, the same real-world location could be just as easily turned into a medieval scene, or anything else that you dream up. Every game object is annotated with rich metadata, allowing you to make styling decisions based on the real world. For example, if we roll the video, here we go. OK, so you can turn, for example, shops into chocolate bars, or buildings into restaurants, or change the heights of buildings. Through simple customizations such as these, you can create unique game environments that still feel connected to the real world. OK, so now that we've established the look and feel of our game, let's add some location-based gameplay. For example, let's add missions and spawn points at prominent locations around the world. The Playable Locations API lets you build your game once and have it work anywhere around the world. We use a vast array of Google Maps signals to determine the best places for gameplay and AR experiences ranked by prominence and popularity. You can request points at whatever density your game requires and fine-tune the way that those points are distributed in a way that is unique to your game. Let me show you a visualization of how this works. So the green dots that you're seeing here are playable locations around the player. Let's turn the most prominent of these into mission points so that people have somewhere nearby that's recognizable to play. Here we're going to represent missions as rainbow arches, just to fit with the theme of the game. OK, the Playable Locations API also includes rich metadata, so you can customize the type of gameplay that you associate with each location. For example, you could put virtual candy stands at real-world store locations. Or, as another example, you could spawn gummy bear characters at restaurants. And these might be a really great choice for your multiplayer experiences since people tend to meet up in groups at restaurants. And if instead you were creating a fantasy game, these could instead have been dragons and treasure chests. Or if it was a futuristic game, it could be spaceships and floating loot. Whatever your game, you get to focus on the fun part of creating rich, engaging gameplay based on the real world. Keep in mind that all of this is happening inside of Unity. And so if I was to press stop, you would see that the scene is empty because everything is generated on the fly. We include lots of other features to help you build your game. such as 9-slicing for applying custom textures to arbitrarily sized buildings, and decorators for adding parapets and other geometry to the tops of buildings, or borders around roads and buildings for simulating ambient occlusion contact shadows. We give you access to the names of roads and buildings, and integrate with Unity's lighting and skybox system so you can create a beautiful day-night cycle. We also support Unity's level of detail system, automatically fading out distant geometry to maximize mobile performance. And finally, you have access to Unity's physics engine, allowing you to use the world's geometry in any 3D physics-based game. OK, enough about features. Next, I want to show you some examples of just how far you can push this platform that we've created. So the technique used to create this scene is a little different to the previous examples. Instead of applying custom textures, procedural rules were used to assemble a high-resolution city out of modular asset packs based on the real world's layout. Down below, you can see cars driving along roads, bus stops, lampposts, power lines. As we zoom in, you start to see just how detailed the street level is. There's trees, cafe tables, shop fronts, people walking around. Even though the technique used here is much more sophisticated, it's the same rich semantic model of the real world provided by the Maps Unity SDK that makes all of this possible. Let's look at another example. So even though this scene looks a little different to the previous one, it's actually using the same technique, just with a different set of assets. The way that the buildings work here is really cool. They self-assemble themselves out of modular components using all of the metadata provided by the Maps Unity SDK, creating in essence a stylistic interpretation of the real world. Or to put it another way, the cityscape is grown organically to match the real world. What's amazing is that these examples were created by a single developer in only a few weeks. His name is Adam Goodrich of Procedural Worlds. As you can see, he was able to achieve an incredible level of detail in such a short amount of time. Let's look at one more example before we move on. So this is a road running through Glacier National Park in Montana. The trees, rocks, and clumps of vegetation were procedurally generated down to the level of individual blades of grass. Elevation data was combined with the Maps Unity SDK to create a vast open world, complete with rivers and lakes, mountains, towns in the distance, animals, wilderness areas. What I love about this final example is it shows that you're not just limited to busy urban centers when creating rich, engaging game worlds. And with that, I'm going to hand you back to Clementine.
Thanks, Patrick. We need to go back one slide. Excellent. So to summarize, Patrick showed you 4 things that we want to help developers with. The first is we want you to be able to build your game once and then make it interesting everywhere in the world at global scale. So you'll have access to hundreds of millions of 3D buildings, points of interest, roads, rivers, landmarks, cafes, etc., to form the foundation of your game world. And this all relies on that same model of the world that Google Maps has been building since 2005. So you'll have accurate and fresh data no matter where your players are. The second piece is that we want you to be able to completely customize this game world. So you can turn rivers into lava flows, or fill parks with trees, or oceans with waves. You just saw a huge range of examples of things that have already been done. You can do simple things like customize colors or textures, but you can also swap in entire prefabs like you're seeing here. Third, we want to help you design gameplay around real-world places. Find the right locations for each type and category of mission or player or in-game reward. You could drive your players to popular places like restaurants and town squares, or take them off the beaten path, and the choice is yours. Either way, we want to help you deliver an experience that's unique to your game and fits your gameplay anywhere in the world. And finally, we want to help deliver these really rich experiences at global scale. So relying on Google's infrastructure will mean faster response times, scale on demand, and also just the peace of mind that comes with knowing that your game will just work. So that's an overview. The last video I want to show you is a bit of what developers are already doing with this. So last year we started a trusted tester program. And we've been working with some of the top mobile developers in the space who wanted to launch real-world games starting this year. Today I'm going to show you 3 of those games. So first up, we have Jurassic World Alive. This is the second installment of Ludia's Jurassic World series, and it's been created in partnership with Universal Studios. So in this game, as you explore the world, you're also hunting dinosaurs, and you're collecting their DNA so that you can clone them and create your own dinosaurs. So next up, we have Ghostbusters World. This is a location-based AR collection game. So this game features first-person shooter mechanics, and you can also interact with other players in real time as you explore the world and collect and capture ghosts. All right, last up, we have The Walking Dead: Our World, which is based on AMC's mega hit and being built by Next Games. This is a location-based AR survival game. In this game, players explore the world, fight walkers, form alliances with other survivors, and build safe havens. All of these games are coming soon to the real world near you, along with many others. So expect 2018 to be a big year for real-world gaming. We're really excited to play these games and also to see what you will build. For every game, we're going to be bringing the full support of Google to bear. Google is very invested in AR technology and betting big. We're really excited to partner with ARCore to bring their expertise to our gaming partners. In fact, all of the 3 games that you just saw have ARCore-powered gameplay. We're also collaborating with other key teams at Google who are focused on gaming, for example, Google Cloud for your game server needs, and YouTube and Play for promotional help. Fundamentally, we want to make it easier to launch games that move the industry forward, and the rest of Google wants to help. So if you're building a game that features real-world elements, please come talk to us. You can head over to our website, which is listed here, and fill out the contact sales form, and our team will get in touch to get you started. There's also a lot of opportunities to talk to our team during this week at GDC. If you want to learn more and get a chance to talk in more detail, please stop by our talk on the expo floor on Thursday. Our team will be there, and we'll be doing Q&A afterwards. You can also find us at the Google booth, where we'll have demos to play with and developers who have built games with maps that you can talk to, as well as our team. All right, that's it. So before we break for lunch, please copy down this URL and give us some feedback on the morning sessions, and we'll see you back here after lunch. Thank you.